In this question, it is given that let alpha belongs to R be such that the function fx equal to this thing when x is not equal to 0. Alpha, if x is equal to 0, is continuous at x equal to 0, where fractional part of x denotes x minus box x, where box x is the greatest integer less than or equal to x. Then you have to find the correct choice. Obviously, for the function to be continuous at x equal to 0, limit x tends to 0, fx should be equal to f0, and which is alpha as given here. And now, because in this question fractional part of x has come, and we know that in the questions where fractional part of x comes or box x comes, in those questions we should find left hand limit and right hand limit both. Actually, this is a very obvious question arising in the mind of students, that in which questions we find left hand limit and right hand limit both, and in which questions we simply find limit. For that, you will have to see my theory lecture of limit of JEE level. Presently, I will say that I will have to find left hand limit and right hand limit both in this case. For right hand limit 0 plus fx, and because it is given that fractional part of x is x minus box x, and when we are finding limit x tends to 0 plus fx, in that case box x will become 0, therefore fractional part of x will become x, that is it will be equal to limit x tends to 0 plus cos inverse 1 minus x square into sin inverse 1 minus x whole upon x minus x cube. This is further equal to limit x tends to 0 plus cos inverse 1 minus x square, and note that limit of this part is pi by 2, because when x tends to 0 it becomes sin inverse 1, and sin inverse 1 is pi by 2. And we know that if in some part of the question limit of that part is non-zero finite, and that part is in multiplication or division with the whole remaining question, then we are allowed to take the limit of that part. Agreed that we are not always allowed to take the limit of a part of the question, but in that case we are allowed to take the limit of that part of the question whose limit is non-zero finite, and that part is in multiplication or division with the remaining whole question on which limit is operating. Hence, because this is pi by 2, and we'll be writing pi by 2 here, and upon comes x into 1 minus x square, and limit of this part is also clearly 1, that is it is also non-zero finite, and this is also multiplication or division with the remaining whole part on which limit is operating. Therefore we can take the limit of this part also. Only we have got now pi by 2 limit x tends 0 cos inverse 1 minus x square upon x plus. And now presently both are tending to 0, hence either I can use L'Hopital's rule or I use inverse trigonometry to convert cos inverse into sin inverse. That is, I get pi by 2 limit x tends to 0 plus sin inverse under root 1 minus x square whole square upon x, that is pi by 2 limit x tends 0 sin inverse under root 1 minus x square whole square upon under root 1 minus x square whole square into under root 1 minus x square whole square upon x. Again, as this part is tending to 0 and both are same also, hence the limit of this part also becomes 1, and we get pi by 2 into limit x tends to 0, and here we get 2x square minus x to the power 4 upon x. Note that it is 0 plus. It is pi by 2 limit x tends 0, x will come outside and you will be getting 2 minus x square upon x. They will get cancelled and you will be getting pi by root 2. And now I will find left hand limit, and left hand limit means x is tending to 0 from negative side, that is in this case fractional part of x, which is x minus box x, will become x minus 1, that is x plus 1. Hence the question will become limit x tends to 0 minus cos inverse 1 minus x plus 1 square sin inverse 1 minus x plus 1 upon x plus 1 minus whole cube. This is equal to limit x tends to 0 minus, this part is clearly tending to 0 and cos inverse 0 is pi by 2. Hence we are allowed to take the limit of this part because it is a finite number and it is in multiplication or division with remaining whole question, and this part becomes x plus 1 into 1 minus x plus 1 into 1 plus x plus 1. Again, as I told you just now, because limit of this part is 1, which is a non-zero finite number, limit of this part is also non-zero finite number, that is 2. Therefore I take the limit of both of them outside. I get limit x tends to 0 pi by 2 minus sin inverse x upon 2 into minus x. That is, I get the answer pi by 4. And because the right hand limit was found to be pi by root 2, right hand limit is found to be pi by 4. Hence left hand limit and right hand limit are not equal. Therefore it is not possible to find any value of alpha so that the function becomes continuous at x equal 0. Hence A becomes the correct choice.